Today in lesson 5, we're talking about prime factorization. So we need to know what a factor is first. A factor divides a number with no fractions or decimals. So it has to be a whole number. So factors divide numbers evenly. That doesn't mean evenly like 2, 4, 6, 8. That means no fractions and no decimals. So it goes in completely. And prime factorization means you're factoring it into all prime numbers. On your paper, it would probably really help you if you wrote down this list of common prime numbers. Prime numbers are numbers that cannot be factored by anything but one or themselves, so they can't be broken down. So the most common prime factors that we'll use are 2, 3, 5, 7, 11, and 13. There are more than that, but those are the ones that we will use the most. So 2, 3, 5, 7, 11, 13. 9 is odd, but 9 is not prime because you can do 3 times 3 to get 9. So our question says, Paul and Angela are asked to find the prime factorization of 100. Paul claims the prime factorization is 2 times 2 times 5 times 5, but Angela claims the prime factorization is 2 to the second power times 5 to the second power. Who is correct? Well, they both solved it in different ways. So take a moment to read how Paul solves it in the model. Look at how Angela solves it by making a factor tree. And now answer question 2. So for question 2, you should have had something like this. Describe the different methods Paul and Angela used to factor 100. Well, Paul started with 100 and just kept dividing by prime numbers, and then Angela broke it up with the factor tree. So question 3, do Paul and Angela find the same prime factors even though they use different methods? So your answer to question 3 should have been yes, they find the same prime factorization. So the little star there is just a multiplication dot. So 2 times 2 times 5 times 5 is what both of them got for prime factorization. Which I just realized that was the answer to question 4. What was the prime factorization? 2 times 2 times 5 times 5. Now answer question 5. How does Angela write prime factorizations in a simpler form? So Angela just rewrote those factors using exponents because 2 times 2 is 2 to the second power, and 5 times 5 is 5 to the second power. So number 6, whose answer is correct? And explain. So question 6, who is correct? They are both correct. Both, I don't know why that won't get out of there. Both Paul and Angela are correct. Angela just used exponents, so she did one more step. So it was a trick question. They're both correct. Now try questions 7 and 8. I used the factor tree method to factorize 40. I started with 8 times 5. That is not the only option. You could have done like 10 times 4 or 20 times 2. And then every time I found a prime factor, I circled it. So I started with 8 times 5, and 5 is prime. Then I split 8 into 2 times 4 to get 8. 2 is prime. And then I could split 4 up into 2 factors into 2 times 2 to get 4. You can use your multiplication table to help you find those factors. And my prime factorization would be 2 times 2 times 2 times 5. But in this question, it did say to write our answer using exponents. So since we had to use exponents, we had to rewrite 2 times 2 times 2 is 2 to the third power times 5. Now try number 8 and check it with the video. 8 was a trick question. 23 is prime. There's nothing that you can divide 23 by that is a whole number except for 1 and 23. So now you are ready to practice.